Question 4 says, obtain the binomial expansion of the quart root of 1 plus x plus the quart root of 1 minus x. So let's do this binomial expansion. We want the quart root of 1 plus x plus the quart root of 1 minus x. Okay, this is what we want. Now that this is what we want, we're good. All right, so we want this now. I'm going to rewrite all of this. This is how we're going to do it. We're going to rewrite all of this as 1 plus x to the quarter power. This is how we're going to rewrite it. 1 plus x to the quarter power plus 1 minus x to the quarter power. That's how we're going to rewrite it. But do you remember binomial theory? Well, if you don't remember binomial theory, let's jog your memory a little bit. Binomial theory, if we can remember correctly, it tells us that 1 plus x raised to the nth power, 1 plus x raised to the n is equal to 1 plus nx plus n times n minus 1 x squared over 2, and it continues. All right, this is known as the extension to binomial theory. You remember that? Yeah, man. And this we're going to use and tackle this easy question. So let's tackle this easy question using binomial theory. So using binomial theory, the first part, 1 plus x to the quarter, or n is quarter. So overall, this is going to be equal to 1 plus nx. I said expand it up to x squared, so we can stop right there. So it's 1 plus nx, which is now a quarter, times x, plus n, which is a quarter, times n minus 1. N minus 1 is going to be a quarter minus 1, and a quarter minus 1 is minus 3 over 4. Just to check it, I'm going to put it in my calculator. I know it's sad, but don't laugh at me. A quarter minus 1 is minus 3/4. Just making sure. X squared over 2. So that takes care of this part. That takes care of 1 plus x to the quarter. Then we're going to need plus 1 plus nx. In this case, n is a quarter and x is minus x. That's going to be plus a quarter of minus x plus a quarter of, it's now plus a quarter of n times n minus 1. N minus 1 is minus 3/4 times x squared, which is minus x squared over 2. Okay, nice. So come we stay, so boom, and work this out. 1 plus 1 is 2. A quarter x plus minus a quarter x cancel. And then what is this simplifying to be? A quarter times minus 3 over 4 divided by 2. This is minus 3 over 32. And you're going to get minus 3 over 32 here as well. So you're going to get 2 times that, which is minus 3 over 16. So this and this, those two adding together to give us minus 3 over 16x squared. All right. All right, so that's the answer. All of this, it just works out to be 2 minus 3 over 16x squared. You see how much beautiful? Look at this complicated thing. All of it just going to be equal to 2 minus 3 over 16x squared. Math is so beautiful. Nice. Now it says, by letting x equal 1 over 16, find out what is the value of the square root of 17 plus the square root of 15. All right, so we get that. And we want to put x as 1 over 16. So let's put x as 1 over 16. So let's write that. Let x be equal to 1 over 16. If x is equal to 1 over 16, then what we're going to get is, on the left-hand side, we're going to be finding the square root of 1 plus 1 over 16. 1 plus 1 over 16 is 17 over 16. All right. Plus the square root of 1 minus 1 over 16 is 15 over 16. All right. And then this is going to be equal to, put in x as 1 over 16 here. So you get 2 minus 3 over 16 times 1 over 16 squared. So when you put all of this in a calculator, what you're going to be getting is 2 minus 3 over 16 times 1 over 16 squared. And I get 1.99999. So I get 1.99993. All right. Now, let me make some space and finish it up here. Let's make some space here. We're going to finish it off in here. All right, so we're going to finish it off in here. Now look what I'm going to do now. Now right here, so we have the square root of 17 over 16. The square root of 17 over 16 can be written as the square root of 17 over the square root of 4. Over the square root of 16, sorry. All I did was separate it. Instead of having it as the square root of 17 over 16, it's just the square root of 17 over the square root of 16. Plus, we can do the same for here. We can break it up as the square root of 15 over the square root of 16. And then the square root of 16, you just put right here. And that's equal to 1.99993. Now, what is the square root of 16? I know it's embarrassing to say this again, but once again, put it in a calculator. The square root of 16. The square root of 16 is 2. This works out to be 2. So now we're getting that the square root of 17, and it's now over 2, plus square root of 15 over 2 is equal to 1.9993. All we have to do now is multiply through by 2. When you multiply through by 2, you're going to get the square root of 17 plus the quart root of 15, take the quart root of 17 plus the quart root of 15. When you do that now, you multiply 2 by 2, you get 2 times 1.9993, you get 3.99 is the answer. I like to write it to 3 sig fig, but you can write it to more if you want. 3.99, you can even write the other 9. So I get 3.99 is the answer to 3 significant figures. Soft. Test it. Test and find out what is the quart root of 17 plus the quart root of 15. Yes, we're right. So we get the same thing. So that takes care of part A. Soft. Part B. Part B says using, it says show that the coefficient of x to the fifth in the product of x plus 2 to the fifth times x minus 2 to the fourth is 96. Now there are two ways you can do this. If you know Pascal triangle, there's no issue in doing this. But if you don't know Pascal triangle, we're going to use combinations. So this is x plus 2 to the fifth times x minus 2 to the fourth power. I want to show the coefficient of x to the fifth power. So to find the coefficient of x to the fifth power, it's going to be two ways you can do it. Let's do it both ways. Method one. Method one, you could actually expand out everything and find out which one is going to give you your coefficient to the fifth power, or you can say it's going to be the term in x multiplied by x to the fourth term here, plus your term in x here multiplied by your x to the fourth term in here. Those are the two ways you can do it. All right, but I'm going to go with method one. We're going to expand out all of this. So to expand out all of this, you're going to say x plus 2 to the fifth using combinations. It's going to be, when you choose 0 first, so 5 choose 0. So I'm expanding this part first. It's 5 choose 0 times x to the fifth plus 5. Wait, I missed out something. It's times 2 to the 0. You don't want to leave out nothing. You don't want them penalize you for anything. Plus, it's going to be 5 choose 1 times x to the 4, 2 to the 1, plus 5 choose 2 times x cubed times 2 square plus 5 choose 3 x square times 2 cubed plus 5 choose 4 times x times 2 to the 4 plus 5 choose 5 times no x to the 0 times 2 to the fifth. Now this is going to be the expansion of x plus 2 to the fifth. All right, so this is expansion of 2 to the fifth. Now all of this is going to be multiplied by the expansion of x minus 2 to the fourth power. All right, expansion of x times x minus 2 to the fourth power is 4, because now n is 4. It's 4 choose 0 of x to the 4 times minus 2 to the 0 plus 4 choose 1 times x cubed times minus 2 to the first power plus 4 choose 2 times x squared times minus 2 squared. And I know you're probably saying, sir, why are you doing this long method? I want you to understand what we're doing first before I show you the short method. 4 choose 3 of x cubed times minus 2 to the first power. This is cube. This should be to the 1. Sorry. Plus, finally, 4 choose 4 x to the 0 times minus 2 to the 4th power. A lot of work. But we're pretty much done now. So all of this is going to be equal to, you just put all of this in a calculator. This is now x to the 5th plus 5 choose 1. I believe that's 5. Put that in a calculator. 5 choose 1. That's 5. But then you multiply it by 2. That's 10. This is going to be 10x to the 4. So it's x to the 5th plus 10x to the 4. 5 choose 2. 5 choose 2, I believe that's 10. And then you multiply that by 2 squared. And I get 40. So I'm getting plus 40x cubed. Plus 5 choose 3 is 10 again. 10 times 2 cubed. 2 cubed is 8. So that's 80x squared. 80x squared. Plus 5 choose 4. 5 choose 4 is 5. And 5 times 2 to the 4. 2 to the 4th power. I know it sounds sad. 2 to the 4th power. That's 80. It sounds sad to be using calculator for that. It's 80x plus 5 choose 2. 5 choose 5. 5 choose 5 is 1. That's just 2 to the 5th. 2 to the 5th is, I don't need calculator for that one. I know that's 32. So all of that is now being multiplied by 4 choose 0 is 1. X to the 4. This works out to be x to the 4. 4 choose 1 is 4 times minus 2, that's minus 4 times minus 2 is minus 8. That's minus 8x cubed. Then 4 choose 2 is 4 choose 2. All right, put it in a calculator. 4 choose 2 is 6. And 6 times minus 2 squared. Minus 2 squared is 4. 4 times 6 is 24. So I didn't need a calculator for that one. That's 24x squared. Then you have 4 choose 3. Oh God, 4 choose 3. I can't believe I can't remember these out of my head. 4 choose 3 is 4. 4 times minus 2 cubed is minus 32. This is minus 32x. Then I definitely know 4 choose 4 is 1. Minus 2 to the 4 is 16. And they want the coefficient of x to the 5. Now look how we're going to find the coefficient of x to the 5. All right. Now to find the coefficient of x to the 5, guys, it is simple. Let me put it in red. It's going to be x to the 4 is going to, when you multiply x to the 4 times 80x, that's going to give us coefficient. That's going to be able to give us 1. All right. you have all of this, guys. We're not going to sit and expand all of this, but what I'm saying is when you multiply x to the 4 times 80x, that's going to give us something in x to the 5th. All right, so this one will give us, for coefficient of x to the 5, I'm going to write c for coefficient of x to the 5th. For the coefficient of x to the 5th, 80x times x to the 4, that's 80x to the 5. Then what else we're going to need to multiply? We're going to need to multiply 80x squared times minus 8x cubed. That's going to also give us something, 8x to the 5th. So 80 times 8 is 80 times minus 8 is minus, that looks like minus 640. So you get minus 640 x to the 5th. Then what else we're going to need? We're also going to need to multiply this 40x cubed by something x squared. So 40 times 24, that's going to give us 960 x to the 5th. I'm going to change the color now because I really want us to keep following. Now we're going to multiply this x to the 4. It's going to need to multiply by something x right here. So when we multiply those two, we're going to get 10 times minus 32. I don't need my calculator for that. I know that is negative 320 x to the 5th. Then we're going to need to multiply this x to the 5th term by the constant, which is 16. So we get plus 16x to the 5th. All right, so now when you add up all of these now, I'm positive you're going to get 96. Let's check it. 80 minus 640 plus 960 minus 320 plus 16. Yep, I get 96x to the 5th. So I get 96x to the 5th. Hence, the coefficient of x is 96. So you can say, hence, the coefficient of x is 96. Now, I know I said I was going to do it the other way from the start, but being that it's so long, I want you to just check out the video on binomial expansion. Look at the examples that we do, and you're going to see us using that method doing other examples, and you'll follow there. All right, so this is just method 1 to do this. Okay, next part of the question. It says, use the IVT to prove that x cubed minus 25 has a root on the interval 2 to 3. All right, so use IVT to do that. All right. Use IVT. So first thing, I'm not going to write it as x cubed. I'm going to write it as x cubed is equal to 25. And so I'm going to subtract 25 from both sides to get x cubed minus 25 is equal to 0. And then I'm going to call this function g of x. I'm going to call it g of x. Didn't want to say f because everybody's going to use f. I like when my paper is different. So g of x. Now the next thing you need to do is tell them that, well, g of 2 is equal to, plug in 2 here, you're going to get 2 cubed, which is 8. 8 minus 25 is minus 17, which is less than 0. And then g of 3 is going to be equal to 3 cubed, which is 27. 27 minus 25 is 2, which is greater than 0. Aha, so good. So now we can tell him, say yes. By IVT, we're good. So now we can write our conclusion that, so we can tell him first and foremost, g of x is a continuous function on the interval 2, 3, and g of 2 is less than 0, and g of 3 is greater than 0, and so hence by IVT, which means intermediate value theorem, hence by IVT there exists a C, which is an element of the interval 2, 3, such that g of C is equal to 0. Hence, there exists a root on the interval 2, 3. All right, so that's IVT for you. Soft. Hence, there's a root on that interval. Now it says the procedure used, they use A as 2 and B as 3, and it wants us to find an nth iteration. From the table, we're going to do this, and we're going to find the approximated root. So let's put up our table now. This is so easy. We're doing bisection method here. So we put up our table for part 2. All right. So up here was n. Then you have A. Then you have B. Then you have Pn. I'm going to put P of n. Okay, I'm going to put B of n. I'm going to put A of n. Then right here, it is, I'm going to call it Fp of n. Okay. N was 1, 2, 3, 4, 5, 6. Going down. And AN, they gave us that was 2, 2.5, 2.75, 2.875, then B end was, for B end we had 3, 3, 3, 3. Pn, we had 2.5, 2.75, 2.875, 2.9375. Then we need f of Pn minus 9.375 minus 4.2031 minus 1.2363 and 0.3474. Okay, nice. So this is what we have now. Okay, all right. It says complete the table to obtain an approximation of the root of the equation x cubed equal 25. All right. So all they did now was, if you notice, when it is 2 and they use 3, the midpoint of 2 and 3 is b. So this Pn represents midpoint. Then they work out what is f of Pn. So what they do is they put in 2.5 in this function. So if you put in 2.5, you're going to get 2.5 cubed minus 25. That's how they get this value. So they do the same all the way here now. And so since they get 0.34 right here, when the midpoint is this is positive. We don't want it to be positive, all right? So how much more they want us to do it? We just need to repeat it 2 more times, all right? Now, the root is not between 2.875 and 3. So now we're going to use 2.93. We're going to use now 2.93 and 3. So AN is now 2.93, 2.9375, and BN is, well, since it's positive, we're not using 2.93, my mistake. Oh, how did those go away? Oh boy. How do we get this back? Control Z. Okay. All right, we're good now. Control Z, take my time. All right, good. So what we're saying now is that the root is going to be between 2.87 and 2.9375. So this is going to become 2.875, and over here is 2.9375. The midpoint of that is 2.875 plus 2.9375 divided by 2 is 2.90625. Then you put that in the function up there for g. So that answer cube minus 25 is negative 0.45, negative 0.45297. Okay, good. Now that we have this now, we need to do it one more time. So this is the 5th one. Let's do it one more time now for the 6th one. So for the 6th one, all right, since it's minus, then we're going to keep this Bn value. And so right here now, this becomes 2.90625. That's now AN. BN is going to be the same, 2.9375. Then Pn is the midpoint of those two. So you add them, 2.90625 plus 2.9375 divided by 2, which is 2.921875. And then you find f of Pn, you put that up here, so you get answer cube minus 25, you get minus 0.0549, all right? And so almost get the answer. Remember, you get the root when this is equal to 0. When f of Pn is 0, that's when you get the root. Since we get another negative, here we're going to put an we're going to change it again now to 2.921875. Bn remains the same as 2.9375. Then we take the midpoint of those two, 2.921875 plus 2.9375 divided by 2, and the midpoint is 2.92685. Then f of Pn is the answer cube minus 25, and we're getting 0.1457. All right. Now, of these two, which one is closer? Of these two, which one is closer? This is closer. This is closer to 0. This one is closer to 0. So what does that mean? Since this one is closer to 0, we can take this as an approximated root. So we're going to take that as an approximated root. And so an approximation of the root is 2.921875. Nice and easy. That's an approximation of the root. Soft. Now, in reality, the root would be the cube root of 25. And the cube root of 25 is 2.924. That's the cube root of 25. But this is a good approximation. All right? Because I just wanted us to complete the table. So that's it. The approximated root is 2.921875. That takes care of module 2. So we're going to go on now to module 3.